So my problem is 3.6.12, finding the graph of f of x equals x plus 2 over x. So the first thing you want to do is find your x and y intercepts. You have no y-intercept, so just leave that. X-intercept is going to be at negative 2 because x plus 2 set equal to 0 is going to be negative 2. Your vertical asymptote is going to be at x equals 0, which is because your bottom here, when you set equal to 0, is going to be equal to 0. This is also because when looking at the domain of the graph will be undefined at x equals 0. So you find your horizontal asymptote because at y equals 0 because the two powers of the leading powers will be 1 to 1, so it's y equals 0. So then you want to find your critical points, well, your max and mins, but you have to find your critical points to do that first. So you want to take the first derivative of f of x to find that, which I've already done here. Okay, so you have f prime of x equals to x squared minus 2x plus 4. This is just doing quotient rule to find this because x squared is going to be x to the 4th because the quotient rule. So it's going to be x squared times 1 here. Alright, so x squared minus 4x over x to the 4th. You can substitute an x out. You can take an x out, so you have x over x quantity x plus 4, and then you have over x to the 4th. You can cross out an x to the 4th, make it x cubed, so you have negative quantity x plus 4 over x cubed. So you have negative 4 as a critical point here. So everything less than negative 4 is going to be positive, everything greater is going to be negative, which makes it a maximum because looking at the first derivative, everything a positive on the first derivative is slope, so you have this positive slope going up here, and then you'd all of a sudden change to negative slope, which have to mean a maximum would be here. So that's why. Alright, so then you can solve for your maximum point. Looking back on the main paint page, you look at f of x equals this, so you plug in 4 for this equation. So you have negative 4, negative 1 over 8 when you plug in negative 4 here. And this would be your maximum. So then you want to find any inflection points or points of concavity change. So this is what you want to do here is find the second derivative by taking the derivative of f prime. So here we go here. You have x cubed minus whatever this is. This is just the quotient rule again. So when you simplify it all down, you have 2 times x plus 6 over x to the 4th. Okay, so then that would mean you have a inflection point at negative 6, a possible inflection point, that is. So you have everything less than negative 6 is going to be a negative, I guess would be concave down, and then positive, a concave up here from everything positive, everything above negative 6. So looking back at your original, you plug in negative 6 and you get negative 1 over 9. So this means you have an inflection point at negative 6, negative 1 over 9, where it changes from concave down to concave up. Okay, so let's graph. Let's graph, say, negative 1, 2, 3, 4, 5, 6, and then you have negative, well, we'll make this all the way down to negative 1 here, negative 1, so you can say this is negative 1/8, negative 1/8, negative 1 over 9. Okay, and then this would go to negative 1, 2, 3. Alright, so you have x-intercept first at negative 2, negative 1, 2. And you think that this is wrong because you also have a horizontal asymptote here at y equals 0. But it's actually right because sometimes a graph can go through the horizontal asymptote, whereas it would be unable to go through a vertical asymptote. And this is one of those situations. So let's draw in the vertical asymptote. Okay, so then you want to draw in your maximum, which would be negative 4, negative 1, 2, 2 through 4, negative 1/8, right here. And then your inflection point, right here. And then you can draw your graph. Start here. And then it would hug the vertical asymptote here. And then this would go down to hug it would start off hugging the vertical asymptote and move to hug the horizontal asymptote here. And that's how you graph this problem.